So, over the next couple lessons, we'll be talking about divisibility rules and giving a couple examples about them. So first, in this lesson, we'll be giving the divisibility rules for 3 and 9. They're very special. So let's start off with 9. Now, pick a number. I'll tell you if this stuff is about 9. Okay, if you pick 72,945, then you're the luckiest kid in the whole world. Okay, if you tell me if this is a division by 9, I'll say it's too easy. Okay, I know you might be freaky out, but you don't even have to use a single rule for this. Since I know this number, it's just 72,000 plus 900 plus 45. And then all those 3 hunks, they're all multiples of 9. You know, if you add a whole bunch of multiples of 9, you get another multiple of 9. So, you don't need a rule for this. So what about this number? Again, if you chose 500,000, 505,000, and 50, then you're the second luckiest kid in the whole world. So, I will tell you, this is not a multiple of 9. But, if I change this to an 8, then this is a multiple of 9. I know, you'd be freaking out again. I mean, how do I know if this is a multiple of 9 or not? And it's so fast. I mean, I didn't even have to use law of division. So now, let me explain why to you. It's a little complicated, but to know all this complicated stuff, you first have to know a little bit more about remainders. Those are all some easy problems. What's 10 divided by 9? Remainder. Well, it has remainder 1. Same thing with 20 divided by 9 has remainder 2. And 30 divided by 9 has remainder 3, right? That was pretty easy. What about 70 divided by 9? Well, if I draw 7 bars, and each of those bars has a remainder 1, since each 10 gives you 1 extra, I'm going to have a total of 7 extras. So, 70 divided by 9 has remainder 7. Okay, so that was pretty easy. What about 100 divided by 9? Well, 100 is 1 more than what? Yeah, it's 1 more than 99. 99 is 9 times 11, so 99 is a multiple of 9. Then 100 is 1 more than a multiple of 9. So when we divide 100 by 9, we get remainder 1. What about 700 divided by 9? Well, each 100 gives you 1 extra. There's a total of 7 extras, you get remainder 7 again. That sounds pretty familiar to you, right? And I think you can see what's going with this. If you try 1,000 divided by 9, well, 1,000 is 1 more than 999. So we get remainder 1. In fact, every power of 10 divided by 9 has remainder 1. For example, 10,000 is 1 more than 9,999. And 100,000 is 1 more than 99,999. And a million is 1 more than 999. That's just nothing. So, I know, you might be thinking, what does this have to do with anything? But, now that you know all about these, so a number that's like 300, 6,000, and stuff like that, it's easy to tell if it's divisible by 9. Let's look at your first digit. We get remainder 6. But I want to tell you about this too. For example, 300. Why does all this work? We have 3 times 100, right? And then I'm going to use the distributive property. This is up to 3 times 99 plus 1. And which equals 3 times 99 plus 3 times 1, and that's just 3. So this is a multiple of 9, and then we add on 3, so we have a remainder of 3. We just look at the first digit. So, now try 504 divided by 9. Try that. Well, I know 504 divided by 9. I know 500 divided by 9. That has remainder 5. 504 is 4 more than 500, which is 5 more than the multiple of 9. So, 504 is 4 plus 5 plus 4 equals 9 more than a multiple of 9. But if I start off from a multiple of 9 and add 9 more, I get to the next multiple of 9. But look what we've done here. We just added all the digits of the number. Okay, we didn't add the 0, but the 0 doesn't contribute to anything. So, this is a multiple of 9. Get what I mean? Now, try another one. Try 663. So, we're going to use the same trick here. I mean, this is divisible by 9. So, maybe not. Well, it's tricky. Anyways, so I know 600 is 6 more than a multiple of 9. And 63 is 0 more than a multiple of 9. So then we just add 6 and 0 to get 6 more than a multiple of 9. So 663 is not a multiple of 9. But here we didn't exactly add the digits. But if we do, you'd see that the number is not a multiple of 9. For example, if I add 6 plus 6, I get 12. We add on 3, that's 15. 15 is not a multiple of 9. But so maybe this way, it's just easier to add up all the digits the other way. So now you see why, right? So adding a number of digits, let's take a little conclusion. Adding the digits in the number gives you how much more the number is than a multiple of 9. So for example, 3,888, it's, well, I know you can do it the old way, but I can just add 3 and the 3 eighths. So 3 times 8 is 24. We add 24 and 3, we get 27 more than a multiple of 9. But if I start off from a multiple of 9, add on 27. 27 is 9 plus 9 plus 9. So I add on 9, and then 3 more 9s, I get another multiple of 9. The multiple of 9 is 3 more. So 3,888 is in fact a multiple of 9. And now let's go back to the 3. Now that you know multiple of 9, 3 is easy. Since 9 is just 3 squared, it is the same rule. For example, again, we'll just use 3,888. We saw that was 27, which is 3 times 9. And it's a multiple of 3. So this is 9 more 3's than a multiple of 3. So it's the same thing. It's 3,880 not only is it a multiple of 9, it's also a multiple of 3. This is how we define it. Any number that's a multiple of 9 has to be divisible by 3. It also has to be a multiple of 3. But not every multiple of 3 has to be divisible by 9. It doesn't go the other way. I'll give you 2 examples. For example, every square is a rectangle, but not every rectangle is a square. And here's a funny one. All pigeons are birds, but not all birds are pigeons. I know, that's pretty funny. Repeat it, okay? Repeat it after me. All pigeons are birds, but not all birds are pigeons. For example, they got the mockingbird. So, I want to tell you one more thing. This has nothing to do with not 3 and 9. But I want to tell you something. There is no divisibility rule for 7. I don't know, you might have been wondering for this for a long time. I was hoping for somebody to tell you. I think I can tell you, but I can't either. There's no very good rule for 7. You have to compute it. Bleh.